Um, wow, can't hardly believe we're the final day of TechCon 2025. So let's make the most of this, this opportunity. So hi, I'm Steve Peck, kind of sales leader for automation. Um, I'm going to be your host for day 3. Uh, if you're new to us, let's talk. Ask questions in chats. We're going to take a poll. We're looking forward to another great session. And Don is going to actually talk to us about AI and increased omni-channel sales and profitability. And so with that, I'd like to hand it over to Don.
Good morning, good afternoon, good evening, wherever you are. Hi, thank you, Steve, for that great introduction. My name is Don Bauer, and I am a sales leader for order management across the Americas. I also have a role as a value consultant. So what I look at is how can order management or how can our tools and technology provide value back to the business? So how do we take the solution, take the technology and translate that to a monetary value for our clients? So it's kind of a fun role. I've been doing this for a good number of years, and I apologize. I'm a little more casual today than usual. We are taking our grandkids through some of the national parks, and I'm coming to you from actually right now from the eastern parts of Montana. But glad to be here with you, and I hope you enjoy this session. So let me jump in a little bit here. All right. Today we're going to talk about Sterling Order Management. We're going to talk about how we're using AI within the solution. And I just want to take a few minutes up front here as we go through the content. And I want you to think about this. Almost every one of us, and I'm guessing all of us, have placed online orders. Order management is that tool behind the scenes that looks at and says, where is that inventory? Where is that product? It's doing all of the behind the scenes. How do I route your order? So we're going to go through a lot of this, and how do we translate that back and make that order more profitable to the business? How do we deliver a better experience to the customer? And how do we ensure that you as a consumer are getting the products you desire, getting that order filled in the most efficient way, maybe the greenest way, the most profitable way, and at the lowest cost so you can get it when you need it at an affordable price. So that's what we're talking about. It's all that behind the scene that goes on when you place an online order. And this applies whether you're buying something for yourself or whether it's a business making a purchase. So, all right. What I'd like to go through today is the need. Why do we need something like Sterling Intelligent Promising? Why do we need this AI solution that sits on top of an order management or a rules-based type solution? Then I'll talk about things around dynamic inventory. So the more we want to get to making a commitment, we need that real time, the ability to understand inventory, what's the status of it, and give you that answer immediately while you're still shopping potentially, before you even get to checking out your order. We want to make the promise to you, and more importantly, if we make a promise and say we will have it in today, tomorrow, 2 days, within the week, whatever that is, we want to make sure we deliver against that promise. We want to optimize the fulfillment so we can give you the lowest cost to fill that order, as well as manage the lowest shipping cost. We want to avoid, if we pull the item from a location, how do we avoid going out of stock so we don't miss a sale? How do we avoid things sitting at the end of the season and going into markdown or clearance? And let me just spend a minute, because it's important, the subtle difference between a markdown and a sale item. As we talk about this today, markdown is that end of season. It's I have an item that I'm no longer going to carry. It's the Christmas item that you're only going to sell at Christmas. So the only way to get rid of it after Christmas is mark it down 50% off, 75% off. It's the swimsuit as you're going into winter, and you mark down to clear those out so you have room for other items. It's a permanent price reduction, where a sale price is, we put it on sale, we bring it back to regular price. Markdown is accounted for differently, and that's why that's important to the retailer. very important is the ability to explain all these decisions, because the adoption of tools and technology is driven by how do I explain? Why did you make a decision that was different than I would have made? And why did AI do something completely out of the ordinary to fill that order? Why did it ship it across the country when I had one locally? And maybe it was because if we took the one from across the country, it was going, we avoided going out of stock and losing a full price sale, and it was cheaper to do that overall. But being able to explain that is what drives the tool's adoption and usability. Excuse me. Then the ability to report back. What are the benefits that you're achieving? How did you achieve those? So we'll go through that. We want to deliver on these goals, and we'll spend some time on the architecture. So I hope I enjoy this. This type of stuff excites me, so I hope it excites you as well. One of the things that we found is over 50% of shoppers say they would cancel an order if there's a mismatch between when you perceived you were going to get the item and when you're actually given the delivery date. So if we can't commit that delivery date up front and keep that, we have potential of customers canceling their orders. And realize there's a big opportunity, because online websites and online shopping, only a very small percentage of customers actually make a purchase when they go online. The national average is 3.2%, and some sites run better, some run worse, but there's a lot of opportunity for improvement. So a 50% cancellation rate is very significant. And then 70% of shoppers say they're less likely to shop with a retailer again if the order isn't delivered within a couple of days. So the whole Amazon effect, where Amazon has been out there and pulling through these pulling through and moving up delivery and performance and expectations. Now that expectation is on every retailer, every business that's out there. And if you get to the point where you've put together your whole cart, you have it ready to go, you go to place your order, and you suddenly get a message that one or more of the items you had thought you were buying is out of stock, or it's going to be back ordered. Well, 52% of the shoppers just abandon their cart at that time. So the ability to have that real-time inventory, make a commitment, keep that commitment, becomes very important when you're talking about numbers of 50 to 70% of shoppers abandoning on you. So how does Sterling Intelligent Promising address this, and what is some of the solution that we're going to talk about today? We want to be able to very seamlessly adjust to this variable demand that you have, and realize when I talk variable demand, especially on retail, you have bubbles of customers come online and they shop in the morning, and they then go to work and they shop in the afternoon or at lunch. So there are peaks and valleys in how you're getting this demand that's coming in for online orders. The same is true for retail orders in store. And then you add on top of that seasonality, where you have things around Christmas, where you have high volumes. Maybe 60 to 70% of your business as a retailer is done directly in that that 3-month holiday season from October through December. Point is, you need that demand. You need to be able to auto scale. You need to be able to support that. You need to have an accurate and a real-time inventory position. Inventory is constantly moving. You have inventory that you own. You have inventory that you have availability to from your suppliers. You have inventory that is sitting in your stores. You have inventory that's been returned to you. So all of this is inventory that you need to, and you have inventory that could be in a customer's cart within the store at any given time. So how do you manage that through safety stock? How do you manage that through getting updates for what was sold almost instantaneously, so you can keep that inventory position accurate and make sure when you make a commitment and you say, yes, I will have this ready for you to pick up in that store in 15 minutes, in 1 hour, that they really still have that item, that it's been picked, that it's available, and I can hand it to you when you walk in the door. So that's that accurate inventory view. We want to ensure the availability and avoid overpromising. Now, there are instances where overpromising becomes a factor. We know there are certain, totally online customers that they have a standard of some percentage of customers will cancel orders. So we want to manage that. How do we ensure either we don't overpromise or we stay within our overpromise limits? Just think of it like airline seats. We know that some percentage of customers will not make a flight. So how do we ensure that we keep all the seats filled? How do we ensure that we meet the demand for all the orders without overcommitting and having to tell the customer something they really wanted is not going to be available to them, or it's going to have to be back ordered? We want to give a very accurate, if I tell you that you're going to have that order within 2 days, I want to make sure that I'm really going to deliver that within 2 days. And there's a lot of reasons. It's one thing for sites to say, I will get you an item within 7 days, and then I delivered it to you early. Well, delivering early is not always a good thing. You may have it then sitting on your porch. It may be something that is damaged by rain or frozen or whatever. There's a lot of reasons. Or it's a gift to a family member, and because it came 2 days early, they got home before you, and there's your gift sitting on the porch. So it's a lot of reasons. Giving an accurate delivery date and being able to adjust for things that go on in the process. Yeah, we gave you a delivery date, we committed it to you. Well, we go to fill it, and for whatever reason, that item wasn't available at the location we thought. How do we quickly reroute that order so we get you that item in the 2 days, even though we've lost 1 day in the initial fulfillment? And then we want the AI optimization. So how do we manage the costs? As we've gone to more of an e-com type environment, we have, and from the historical where customers primarily shopped in stores, we've incurred some costs at here. So now you have shipping costs, you have picking costs, you have these other, and how do we start to take and pull back on some of those incremental costs that have been created and make sure that you're profitable? And this has to do with both pre and post purchase. So while you're looking at the item, I want to commit it to you. I want to make sure I can deliver it to you. But post purchase, how do I avoid pulling an item from a location where there's high demand for it and I lose a sale? So maybe it's winter in the north, and if I have a swimsuit and it's someone in North Dakota, Montana wants to order that swimsuit, well, maybe I fill it from a location close by, but the reverse is true. What if someone in Florida wants one, and I know they're selling very well in Florida? Maybe I pull it from North Dakota because it's not going to sell for me till, for another 2-3 months from now. So it's looking at all of these things and avoiding that lost sale and the profit that you would have on that lost sale. So that's what we're looking at. That's the type of solution we're going to talk about today. I'll go a little bit deeper here. It is a single platform, and we've already talked a little bit about. I'm going to go around the circle here from left to right, but enterprise-wide visibility to that inventory. We want to look at all the inventory, make sure we have all the options of where we can fill the order. What is the contextual availability? So what's the status of that item? When can I really get it to you? Can I control? Is there any inventory control that I need to put on it? So are there certain items that maybe I can't ship, or I want to, I have some special status that has to be handled with them? Can I promise it to you? When can I promise it to you? If you pick it up in the store today, how do I deliver that? Again, I go back to that Amazon-like experience. We want to be very specific at the individual item within the order but also managing the entire order. We want to make that promise and, end to end. I make the promise to you. Now I'm going to ensure that I keep that promise to you. And then I want to have these business objectives. What's the most important thing is, do I ensure that I make the committed delivery date? Do I ensure that I manage profitability? So if I have something, am I willing to expedite that order? Is it profitable enough in that order to make sure I want to, should I really send it to you overnight to get it to you? Or is it a $2 item that maybe it's not worth doing that for certain items? All business decisions that you can start to put into your objectives and understand what's the cost to fill that order. And that could be labor, fill rates are much better in a distribution center. I have better shipping rates with carriers. But however, maybe in a store, I have a store that's very slow, volumes, and I have almost free labor because I have people sitting in that store waiting for customers. So there's different ways of looking at what's that full cost to fill an order. And then I want to give that transparency back to you. What is the the cost of that order, and why did I make the decision that we made? All right. Looking at this in a little different lens, at the top, think about that bar as the customer. We want to improve the purchasing experience as they search, they look for product, they're browsing, they discover what they want. Then we want to make a promise to them. So what is that promise, and how are we going to fill that order? When are we going to get that to you? And when can you set that expectation? We want to have them have a good carting experience, when they check out. And then how do we make it profitable? How do we keep that order, optimize the promise, and ultimately provide the post-purchase experience of, if you want to return that item, if you want to track when is the order going to get to me. Again, it's all built on this concept of having that near real-time dynamic inventory, being able to real-time make a promise, look at lead scheduling, look at carrier schedules, look at pickup times, take all of this into consideration, and then optimize. With all of that information, what is the lowest cost for us to fill that order to make sure we maintain as much profitability as we can for those online orders? So a lot of what I've been talking about here is everything that's going on behind the scenes when you shop online, when you place that order, when you wonder, why did I get the order in 2 shipments? When you wonder, why did it come multiple days early, or why was it delayed, or how was the shipping cost calculated? This is a lot of those things that are going on behind the scenes, and I find it exciting and interesting, and I hope you are too as I go through this. Now, and I know we want to get to some of the technical, but I will carry into that here. But I like to start out with the business side of this up front. So as we're looking at the first piece of that arc that I just showed you on that previous slide, I'm going to jump back to that. Let's go through these different layers here a little bit deeper. For dynamic inventory, again, it's that, how do we quickly get you that information of, is that item available, especially if it's a fast-selling item, or if I know that there's high demand for it. So I want to have that visibility of everything across the enterprise, because it's possible I have that item somewhere. I have it in a ideal location to ship to you, or maybe I have it in a DC, or maybe I can commit it to you in 2 days because I know it's in transit to me and I will have it within 2 days at a location where I can ship it to you. As well, I want to manage it within the safety stock to say it's, again, a high velocity item. So I know they're being picked up in the store, so I want to manage a little higher safety stock when I show you that it's available versus a very slow moving item where maybe I'm not as concerned about that being available because the probability of someone picking up is fairly low.
Hey, Don,
Yeah.
give me a second. Hey, so, this is a lot of great content. I just want to remind everybody, please don't hesitate to ask questions, post them in chat, and then we'll get them to Don. Don's the expert in this space. This is pretty good content, really interesting. Appreciate it, Don.
Okay, yeah, please ask Steve. Thank you for that. I'm glad you pointed that out. So I hope I'm creating a little bit of excitement or interest or a little more insight into what's going on behind the scenes. And I will get into the AI piece of this just coming up here. So continuing on with inventory, it's that when can I make that available to promise date? I have to know the carrier pickup schedules, when they are available to me, what's their historical performance. And then I want to have granular inventory control. So what are the business rules? How do I want to segment that inventory? Do I want to make sure that I always have a certain level available for the walk-in customer in the store, so I never have to deliver on a promise if they've come to my store? All of this is built into that dynamic inventory management. How is it done? How do we maintain that real-time centralized view of inventory across all the different selling channels? How do we reduce the latency? Make sure that we're getting all those updates on what's moved, whether it's in an individual store location, whether it's in a DC, whether it's an online order that's been committed but yet hasn't been picked. And we do that through a lot of standard tools, but you're going to see, for the mass scalability, Cassandra. For all of the event streaming, the high throughput messaging, managing all the brokers, we use Kafka. And then for balancing all of this capacity across the servers, we have Akamai. So built on some standard technologies, built for performance. And we'll get into this a little more later, but traditionally, everything was cached. So if I create a cache, but the problem with caching is, yes, you have very rapid speed to pull that inventory data, but as soon as you created the cache, it's outdated. With the tools we have here, we can get the performance that we need, and we avoid that. How quickly do you refresh that cache? Are you making, incremental updates to it, and how fast you can make those changes? This allows us to give the performance that we need and keeps you more near real time than a cached inventory will even do. So let's take a closer look at that whole, how do we make and keep a promise? And it starts with that pre-purchase. We go online and we want to tell you right on that product detail page when you're browsing, well, if you want this item, you can get it today by going to this store or location. If you're willing to take it in 2 days, we'll ship it to you. If you're willing to wait, 7 days, we can give you the most green option. Okay. Then on top of that, as you add the next item, well, no longer can you pick it up at this location because they don't have both items if you want them today. Now it switches you to a different store location, or it only gives you the option to have it shipped to you. And if you'll wait as you continue to add items, at some point, maybe we say, if you want the most green option, we can consolidate this whole order and get it to you in 4 days or 5 days. Are you willing to accept that? Or we know we have to ship it in split shipments to get it to you and meet a 2-day delivery date. But are you willing, are you willing to take the greener option? And when I say greener, it's because of the fact that every time we run a delivery vehicle out to your house, that last mile there creates some level of greenhouse gases, as well as the incremental packaging. So did we have to provide you with another box? Did we have to put another plastic wrap around it? All of that adds to the environmental impact. And if we can give you the green option and you choose that, it does two things. Obviously, it's very good for the environment. But ultimately, if we can ship it as one order, we typically can reduce the shipping cost and the overall cost to process that order. So we want to, first thing is make the promise. The second one is ensure we keep it. And there are those exceptions that happen when we're trying to make sure we keep it. For whatever reason, you submit a credit card, there's some credit hold, something has to be analyzed, something happened with the inventory, it went to a quality hold. What do we look at? Quickly look at other options to make sure we get it to you and we keep that promise. All right. What goes into making that promise? We need to have, what are all the, so think about it this way. I'll talk about a retailer that maybe has, we'll keep numbers on the low side, even 100 stores and locations. They have a couple of DCs maybe. So the cost to fill is probably lowest in a DC because you have much higher picking rates, you have a lot of automation, you have better carrier rates. However, maybe in that 100 stores, you do have inventory. Maybe one of the items is out of stock in the DC. So if I shipped from the DC, it would cause a split shipment anyway. So why don't I then look at stores that can fill that order? If we're going to look at stores, what's the one? The typical rule is what's closest to you. However, maybe closest isn't always the best answer because we can avoid an out of stock or we have inventory that isn't moving fast in a further location. So we're looking at inventory for your order of 3 items across the 2 DCs, across the 100 stores, and a lot of the options of how would we ship it complete. What if we broke it apart and shipped it 2 items and 1 item? All the different variable options of how we could ship that to you. And we go through those, apply the costs, apply the carrier rates based on the weight and dimensional weight of all the items in that order. And we say, here is the best location to fill that from. And what's the promise that we could make if we fill from that location? Based on carrier pickup times and all of that. So this is what's going into making that promise and making that commitment to you when you place that online order. And the results of this, because you're able to give that order, look at that order ahead of time, typically increases your online conversion in the range of 1 to 4%. And that's people not abandoning their cart because you committed the delivery date up front. It's people taking that cart and not waiting till they get to checkout to find out when it really can be shipped to them. So they know it and they continue through the process and they make the payment, make the commitment to you. Excuse me. And then in the optimization, we want to start where can we take cost out of the order? So we want to look near real time and have those business objectives. Is it about making sure if I commit to you, I'm going to get you the order on time? If I commit to you, am I going to do it only if it is profitable to me? Well, am I willing to take a loss to make that commitment of next day? So suddenly, for whatever reason, the only way of making next day is for me to expedite it. Am I willing to take that loss to get it to you? So you can make those types of decisions. Is it more important to me to manage in-stock positions in stores than it is individual order profitability? All of these can be built into your rules, and we can prioritize customer experience, business profitability, balance those out. And then we also can balance out how do we do this in the most environmentally friendly way. And when you look at orders that are coming to you and all the packaging and all of the excess and the driver coming to your house maybe multiple times a day or even multiple times a week, what is the environmental impact of that? So how do we consolidate those orders? How do we take if you place multiple orders in one day, can we take those and bring those together and ship those all to you as one shipment versus 2 orders? So all of that's taken into that fulfillment optimization portion. And when we look at this, so think about it this way. There are retail transactions that happen in the store. We want to make sure we don't take inventory and cause a lost sale because you can't find what you want in the store. There's e-commerce transactions, and we've talked a lot about those. So there's inventory movement. So there's inventory moving between locations that we have to understand. There's typical replenishment, whether that replenishment is coming through your distribution center or whether it is a supplier replenishing you directly. There is this whole concept of markdown or clearance items that we want to manage and make sure if we have something that's going to go to clearance, do we take it from somewhere that it will probably go to clearance versus somewhere where there's a high probability it would sell before it went to that clearance price. We want to do that to sell at the highest margin possible. We want to balance the fulfillment capacity. We never want to send more orders than a store or a DC can actually handle. We want to manage the processing costs. So I talked about DCs are more productive. Store labor is less expensive. And then store labor varies greatly whether you're in a metropolitan area like New York or whether you're in some rural area like actually where I'm at right now in where am I at? Sydney, Montana. Excuse me. We want to understand all the carrier rate cards. So you have different carrier options. What's the rate they're going to apply? What are their break points? If I put too many more items in a package, when is it going to cross that rate card? So we can pick the best carrier at the location that crosses the least, carrier zones, so you get the best transportation cost. We want to understand the carrier performance, and overall, we talk item weight. It's weight, but it's really dimensional weight. So what's the weight in the cube of the item? Ultimately, we will lower your transportation costs, increase your sell-through at full price, and give you more fulfillment reliability. So these are the goals and objectives that we are trying to do. The current models that we talked about, node performance, are you filling complete and full? Are you doing it at the lowest shipping cost, the lowest processing cost? Are we balancing that workload so nobody gets too many orders and nobody gets 0 orders? Are we avoiding those clearances, and are we avoiding the stockouts? So these are the current models. This is where a lot of our customers are seeing some of the greatest value. Excuse me. This just goes a little deeper into some of the pieces that go behind each one of these models. It's so there's a lot of data that goes into creating these. The shipping model, the load balancing, and the capacity are all done with what I would call multi-dimensional rules-based decisioning. So it's taking in a lot of inputs, but it still is really a rules-based decisioning. The markdown avoidance and the stockout avoidance, those are AI models. They are machine learning models, which are taking into account the probability, because everything at that point, what's the probability of sell-through based on historical sales? So they are probability based. And again, those are machine learning models that are doing that. And then there is some future work on looking at carrier performance. So we know a carrier says they will do 2-day delivery from this location. Are they really performing at that level? Because we can track the order. We can say, we know when we received the order from you. We know when we sent it for sourcing. We know when the order was filled and ready to ship. we know when the carrier picked up that order, and then we know when the customer received it because we get that feedback from the carrier. So if we're finding performance issues where carriers at certain locations are not performing to standard, we can now take that back into the model based on those inputs that we get back from the carriers, and we can start to monitor carrier performance and use that in that whole decisioning up front when we give you an estimated delivery date. So what is the actual probability? Although we know, our internal timeline to get an item order out, now we're taking into account the carrier's performance and the probability they will actually get that order to you on time in full. So those are the models that we're going through. Let me take you through a quick example of this. We'll call them nodes, but let's say it's 3 stores. And I have an item, the shipping cost from store 1, store 2, store 3, $5, $5, $6. Store 1 is really near capacity. It has, a lot of orders sitting in backlog or whatever. The other 2 stores don't. So you see a slight penalty added to, which in turn normally would force, if everything else is equal, it would force that order to a different store to fill. Now, if we pull the item from store 1, there's a high probability we will lose a sale, and the value of that sale on profit is $5. If we pull it from store 2, there's a medium probability, so only 80% probability that we'd lose that $5 sale. Store 3, the item isn't moving, so we can predict that it's going to be almost 0 probability it's going to sell. So now you look at this, if you just went with, kind of the rules-based sourcing, you would say ship it from node 2, because node 1, we had node 1, we had that capacity penalty, so that would have forced it to store number 2. However, when we put the AI model on top for avoiding a stock out, we see that store 1 and store 2 both had the probability of stock out. It actually is less expensive overall, or more profitable, I shouldn't say less expensive, more profitable to you to spend the extra dollar on shipping and avoid those stockouts. So this is what's going on in that AI model as we talk about it. This is just a little more detail. If you were looking at both an order that had the probability of a stock out, as well as we were avoiding a markdown, so multiple items in the order. Now we're trying to make a decision and say, okay, we avoided the stock out. Well, what if we also avoided a markdown within that order? And now we would pick the node or the store location where we had savings on both of those. And you can start to see this becomes fairly significant dollars when you're taking an item that maybe sells for $100 and has a, if it had a 40% gross margin on it, that's a $40 increase in sales based on avoiding a lost sale, or a markdown of $20, and you sold it at full price somewhere else. We avoided that markdown, so we saved your business $20. So these become fairly significant very fast, and a little bit more incremental shipping cost may not be that significant, or it doesn't cover the cost of that avoided markdown or that avoided out of stock. So we want to select the proper location to make the order the most profitable. Key to all of this is that ability to explain the decisions you made. So we go and we say, yes, I had that item available in the store across the street, but I shipped it from 1,000 miles away across the country. Why did you ever do that? And we did it because, let me show you how we avoided a markdown in that order that saved you $20. And yes, we spent $3 more on shipping. Had you not had that ability to explain that decision, there would be a lot of reluctance to implement the solution, a lot of lack of support, because they can see that the inventory was available in the store across the street. But we knew it would sell it, or we were high probability it would sell we would have a missed sale if we took it from there. So this is the thing, this is the importance of that explainability, explaining the decision, and then being able to demonstrate the value that we made from that. And that's in this continuous benefits reporting. So it's taking all of this and pulling it together and saying, what is the actual value that you realized? How much did we reduce shipping costs? So I decided not to ship from the DC. I shipped from a local store. I avoided an expedite fee. How much did we actually save you on each individual order? Or, oh, by the way, there are instances where we predict we were going to avoid a lost sale from an out of stock and didn't happen. We get a penalty for that because we made a bad decision. So the machine learning will continually learn and improve, but anything with AI or anything where we make decisions, there's always the possibility of making a bad one, and those do happen because especially when dealing with probabilities. So continually report those benefits back, give a report to the business, let them understand the value that they're seeing, let them interpret that, let them then make the decision how to enhance the tool, how to adjust some of the settings, how to change it for seasonality, how to do things around, we get into peak season. I want to make sure we have no backlog of orders in our distribution center. So we want to force more orders out. All of this can start to be managed within this intelligent promising and the AI engines. It's about profitability. It's about explainability. We've talked a lot about this already. The platform, the data lake, where we're keeping all of this, the sales movement, making sure you have insights to all of the decisions, and then the integration of all the data feeds that we've talked about that go into this, the carrier rate cards, the dimensional weight of the items, and then finally having the architecture and the performance to support all of this. So what does it mean to the business? I've already talked about the 1 to 4%, giving that delivery date up front, 1 to 4% increase in conversion of your card. Decreased lost sales, out of stock. Typically a retail business, 7% out of stock. That number varies depending what business you're in. Some items like shoes where you have a lot of different sizes and styles, out of stocks can be much greater there, and the value can be much greater. Avoiding the markdowns. So reducing the markdown budget by 1 to 3%, when markdowns can be, 3-4% of a retailer's overall budget. So if they're doing $1 billion, whatever, they're doing $1 billion online, 4% of that is what, 40 million? Maybe they have 40 million. Yeah, maybe they're doing 40 million in markdowns a year. If we can reduce that 1 to 3%, it becomes fairly significant. And then this cost to fill orders and shipping cost. By selecting the location with the lowest shipping cost, maybe instead of always shipping from a DC, we ship from a store. It can just come across town. We can avoid expedite fees. We can reduce split packages where you, as a retailer, you eat the cost for that second shipment. We've shown a 6 to 12% reduction in shipping costs, and realize on a traditional clothing order, shipping costs can be as much as 8 to 10% of an order. So you order $100, place $100 order, you may have $8 in shipping costs, especially if the order had to be split into multiple shipments. It could be greater than that. So reducing that by 6 to 12%, when it's 10% of your e-commerce business becomes very significant. Improve the labor efficiency, sending it to the right store, make sure we balance the workload, reduce cancellations because we got the order out on time and full, reduce split packages, and then make sure all of the deliveries are made on time and full, improving that. All right. So I spent a lot of time on the business side of this. I'm going to go a little bit into the architecture, and I do want to save a few minutes at the end for Q&A. So I haven't heard any questions come up yet. I haven't heard anything come in. I will pause for a second and just see if there's anything anybody would like to hear more on the, what is the tool? How are things working behind the scenes? And how are we applying AI? Steve, anything coming in on the question board?
Nope. You know what? It's been a very quiet chat board for that. It's been very interesting, but very quiet.
All right. Well, I hope I'm not. I hope I'm keeping the interest. I'm answering questions as we go. I hope I'm not off track of or not meeting your expectations. So when we look at the architecture, there are a series of, obviously business services, there's some of the common services, all the data exchange that has to go on, and then there's the AI. It's all done in a one common unified configuration, one unified tenant model, and everything is event-driven architecture. So we are publishing internally, externally. And then we have the data lake, which is included with all of this, the SaaS subscription. So you have all that information. Anyway, when we think about the some of the runtime services that are out there, it's around, we've talked a lot about inventory. It's about that whole promising. It's how do we optimize it? And some of those common services around what's the catalog? So information on every single item. Can it be shipped? Can it not be shipped? What are the rules around how we're going to work with them? What are the carriers that we bring into this? How are we going to provide the information in the search engines? Then there is some of the data exchange services. There's the intelligence. How do we augment that data? How do we build all the models? How do we maintain the governance around those models? And we have this all running on the IBM cloud, and it is offered as a SaaS solution. All right, the inventory service. So within the inventory service, we've talked about inventory visibility. We've talked about optimization. We've talked about the promising. So it is managing, it's that ability to manage all of the supply. It's the ability to understand how is demand impacting supply. I also want to talk for a minute about understanding safety stock, because safety stock is very critical. If you set your safety stock too high, you don't show items for sale online because they're hidden away in the safety stock. If you show items, even though we're near real time, if you show too much inventory online, there's the possibility that you can overcommit. There also is the way of handling some of this of having what I'm going to call dynamic safety stock. So if I have 100 of that item in my enterprise, maybe I show it online no matter what, because I'll find somewhere to fill it from. Maybe I'm not, but if I set my safety stock just at one per location, maybe I don't have any location that has more than one, so I would never show it to you. But I want to show it to you because I have 100 and I have a safety stock that I use for displaying the item and a different safety stock maybe when I go to fill the item. So now I look for the optimal place where I can fill all the items from a single location at the lowest cost. Want to understand all of that against, obviously product availability, as well as if there's any reservations. And Steve, did I hear anything or?
And so it's a case. I just wanted to kind of give it a heads up there. You really only got about 10 minutes left. So as you're kind of looking at the rest of the presentation.
Okay, I will, and I will, I'll try to save, I'll go through some of this fairly quickly here, and then I'll save a little bit of time at the end and see if there's any Q&A or any dialogue people would like to have. All right, thank you. Again, and these slides will be available. This information will all be available to you. So promising service, how do we make sure that we make that promise? I've talked about it earlier. How do we make the promise, apply the optimization to complete that promise at the lowest cost, and do that within the commitment of the time frame that we said we would deliver that to you. So it's all about understanding the carrier performance, understanding shipping dates, understanding time to fill, understanding carrier pickup, time schedules by location. All of this is brought together within the tooling here. Optimization, reducing those out of stock situations where you go in and you look for something and they just pulled it, for the customer. And there are instances where items come out. Oh, I'm going to date myself. The toy that everybody has to have at Christmas, where what you don't want to do is let online demand take all of those. You want to make sure that we keep some of those in the store. So we want to use optimization to pick the right location and make sure we have supply for the customer that comes to the store as well as the customer that's online, or potentially prioritizing customers as saying this is a better customer, so we will make sure their order gets filled, and this is someone who never shops with us, so let's not prioritize them as high. Data classifications, we have all of the how do we set up our network, how do we set up so all the configuration, the processing rules, what are the groups of shipping, all of the transactional data. So what's the availability, what's the supply, what are all of the capacity. Then we have the master data. What's the product, what are the details about its weight, its dimensions, its weight, how does it are there any limitations that it can only ship from a DC because it's some kind of a chemical compound, or it has a battery in it and has special handling requirements. And then we have the AI pieces where we're looking at the historical, the movement, the probability of sales, all of those pieces. All of this is going to get brought together, and we'll put that in, the file, the internal, the external file exchange to create the SIP intelligence. And I know I'm running out of time here, so
Yeah.
yes,
Maybe it's a case where I'm gonna jump in here for a second then. To say, hey, just quick reminder, please answer the survey questions at the very end. There's actually been a lot of great content here and perspective. I wanted to say, hey, there's a office hours at 2:30 this afternoon. And go ahead, Don. I'll let you wrap up.
No, so I would say I've been going through a lot, and I know it is Tech Exchange. I'm covering a little bit on the technology, a fair amount on the business, but I find that technology, in my role, I find that technology is the enabler to the business being able to change or adjust. So I hope this comes across right, but technology for technology's sake, is always interesting, but the true deployment, the implementations, the value it delivers, that's where we get these solutions. That's where businesses say, yes, I'm willing to invest in this. And this is an AI solution that has been out there for, 5-6 years. It continues to get enhanced. It is very focused, obviously, but it's something that you're probably using every day and didn't even realize that you're using it behind the scenes, and how many pieces of information and data are being brought together every day when you place an online order. So with that, Steve, why don't I stop here? There's 5 minutes left. I'll see if there's any questions. I mean, the only thing is you talk about the data lake, and then if there's anything in here that plans or directions, we don't disclose those. So
yeah, and so I'll be looking at the questions at the time. It doesn't appear like there's any questions, at least in the chat. Just a reminder again, we're going to have office hours, if you will, where you can ask any questions that you think might come up, at 2:30. Don't hesitate to provide feedback. Again, we're going to do the survey at the end. Quick reminder to stay engaged with the Tech Exchange community so you can stay in touch with future events that we actually might have. And then what I'd like to say too, as we kind of wrap up here, all these sessions are going to be on demand. You can always visit back and listen to things that you might didn't catch the first time, right? So I would say the next session is going to be next live session here at TechCon 2025 is going to be at 11:05. Hope to see you guys there. And thank you a bunch, Don.
all right, thank you everybody, and enjoy your day.